Okay, good morning. This is Pre-ACE Math 2 Quiz 7 Study Guide, and it is the 8th of October. Alright, question number 1. Which pair of triangles is congruent by ASA? That's angle, side, angle. So here, option A, we've got an angle, a side, and an angle congruent to an angle. Alright, in this problem, the side that's congruent is not included, so we can't use choice A. Choice B, we've got angle, side, angle, and we've got angle, side, angle. So this is an option. Pair of triangles congruent by angle, side, angle. Option C, angle. Side, angle, side, so we can't use C. And option D is another side, angle, side application, so we can't use answer choice D. So answer B is the only pair congruent by angle, side, angle. In problem number 2, can we use side, angle, side, angle, angle, side, or both to prove the triangle's congruent? So in this diagram we have some vertical angles here in the middle of this shape that are congruent to each other. So with those two angles being congruent to each other, we have an angle, angle, and a side congruent to an angle, angle, and a side. So angle, angle, side theorem works. We don't know of any other sides in this diagram that are congruent to each other, so we can't use side, angle, side, which means we can't use both. So it's going to be angle, angle, side only. Number 3, based on the given information, what can you conclude and why? We've got angle H congruent to angle I. I'm sorry, that's an L. H is congruent to L. HJ, this little leg right there, is congruent to JL, which is this side. Alright, now I'm going to blow this up again. Again, we have vertical angles, and this angle on the left is congruent to this angle on the right. So we've got two triangles that are congruent to each other by angle, side, angle. So by process of elimination, we can get rid of answer choice B and answer choice D. So we've got two to choose from using angle, side, angle. And answer choice A says HIJ. So we're starting at H, we're going through I, and then to J. Congruent to L, K, to J. So that looks like a good choice. Let's check this second answer. The second answer says HIJ, which goes here, HI to J, is congruent to, alright, they start at J in this second description when they needed to start at L. So this is not an option either. Alright, so answer choice A. Alright, number 4. RS and T are vertices of one triangle. EF and D are vertices of another triangle. So I would draw those triangles. And triangle R, S, and T, and then triangle E, F, and D. The measure of angle R is 60. Measure of angle S is 80. Measure of angle F is 60. Measure of angle D is 40. EF is equal to 4. Are the two triangles congruent? If yes, explain and tell which segment is congruent to RT. So let's take a look at these triangles. In the triangle on the left, we've got a 60 and an 80 angle, which means our third angle is going to be 80 and 60 is 140. Our third angle is going to be 40. And our triangle on the right, our third angle is going to be 80. The side that connects E to F, or the side that connects the 80 and the 60 degree angle, is 4 units long. So in this other triangle, the side that connects the 80 and the 60 has to be 4 units long. So now the question is, are the triangles congruent? It looks like we've got an angle, a side, and an angle congruent to an angle, a side, and an angle. So I'm going to say yes by angle, side, angle. So this can go away. Yes by side, angle, side. We don't know two of the sides, so we can't use answer choice C. We're not going to use answer choice D. So by process of elimination, we have choice A. Which segment is congruent to RT? RT is the side that touches the 60 and the 40. So the side that touches the 60 and the 40 is FD. Alright, then on these short answers. QRS is congruent to TUV. Q to S is 3V plus 2. So here's Q to S. T to V is equal to 7V minus 6. T to V. Alright, since they're both the first and third vertices in their description, they're congruent to each other. So we need to find the lengths of each of those, and we need to solve for V first. So we got a 3V plus 2 equal to 7V minus 6. So subtract 3V from each side. 2 is equal to 4V minus 6. Add 6 to each side. 8 is equal to 4V. And divide both sides by 4. So 2 is equal to V. If 2 is equal to V, we can substitute. And we'll go up here. 3 times 2 is 6, plus 2 is 8. 7 times 2 is 14, minus 6 is 8. So the length of QS and TV are 8. Alright, in this second congruent statement, ABC is congruent to PQR. Angle B is located in the middle of this description. Angle Q is located in the middle of this description, which means the angles are congruent to each other. So again, we are going to set up an equation where 3V plus 4 is equal to 8V minus 6. So we can subtract 3V from each side. Four is going to equal 5V minus 6. Add 6 to each side. 10 equals 5v. Divide by 5. Again, 2 is equal to v. So when we substitute, 3 times 2 is 6, plus 4 is 10. 8 times 2 is 16, minus 6 is also 10. Alright, short answer number 3. Name the angle included. Sides PN and NM. You can answer this without a picture. Name the angle included by sides. Both descriptions have the letter N in them. So if both segments have the letter N in them, then N is the included angle of PN and NM. Number 4, what other information do you need in order to prove the triangles congruent by side, angle, side? So we need a side, an angle, and a side. Alright, we've got a side in this triangle on the left, and we have a side in this triangle on the right. Both triangles share side AB. So we have two congruent triangles, or we have, two pairs of sides that are congruent to each other. So if we knew this angle measure down here, then the triangles would be congruent by side, angle, side. So if AC is perpendicular to BD, then we can use side, angle, side. Alright, because if these two segments were perpendicular to each other, they would intersect at 90 degrees. And if the left side of this intersection is 90, then the right side of this intersection is 90. And we have a side, an angle, and a side congruent to a side, angle, and a side. Which triangles are congruent by angle, side, angle? Alright, so here I see an angle, a side, and an angle. In this middle case, the angle is not included. It's not, the side. Angle, side, angle. We need a second angle. We don't have a second angle here. Can't use that one. Now over here we have an angle, a side, and another angle. Alright, so which triangles are congruent by angle, side, angle? Triangle UTV is congruent to triangle CBA. Alright, which two triangles are congruent by angle, side, angle? AF bisects EC. A to F bisects E to C, which means this segment, ED, is congruent to DC. An angle AED is congruent to FCD. And then this is another case of vertical angles. These two angles are congruent to each other. So which two triangles are congruent by angle, side, angle? The triangle on the left, I'm going to call it AED, is congruent to the triangle on the right. If we started with A, the angle with no arc marks, we have to start with F, which is the angle with no arc marks. E is listed second, so C has to be listed second. And D is congruent to D. So triangle AED is congruent to triangle FCD by angle side angle. Alright, number 7, we've got an isosceles triangle. We said earlier in the week that in an isosceles triangle, if these two sides are congruent, then these two angles are congruent. So if this angle on the left is 56, the angle on the right is 56. So our x plus 56 plus 56 has to equal 180 degrees. So our x plus 112 equals 180. Subtract 112 from each side, and our x is going to be equal to 68 degrees. Alright, in number 8, we're going to find the value of x. Diagram's not to scale. RS is congruent to ST. So RS is congruent to ST. That gives us an isosceles triangle. The measure of RST, this angle up top, 7x minus 54. The measure of angle STU is 8x. ST to U is 8x. So we need to find the value of x. Alright, we know that these two angles down here in the bottom of this isosceles triangle, those are congruent to each other. This angle here is congruent to this angle here. These two angles form a linear pair, which means that this angle right here is equal to 180 minus 8x. And if that angle equals 180 minus 8x, then this angle equals 180 minus 8x. Which means that these three have to add up to 180 degrees. So we're going to write an equation. And we're going to say that 7x minus 54 plus 180 minus 8x plus another 180 minus 8x all have to add up to 180. So if we combine like terms, we've got a 7x, a minus 8x, and a minus 8x. So that's 7 minus 16, which is negative 9x. We've got a negative 54, a 180, and a 180. So that's going to be 54 negative plus 360, which is positive 306. if we subtract the 306 from each side, then our 9x is going to equal negative 126. And if we divide each side by 9, I'm sorry, this is negative 9x equals negative 126, so we need to divide each side by negative 9. Our x is equal to 14. Alright, number 9, two sides of an equilateral triangle. So we've got an equilateral triangle where all the sides are the same. Two sides of an equilateral triangle have lengths of 2x minus 2, 3x minus 6. Which could be the length of the third side? They're asking if this third side is 10 minus x, or is it 6x plus 5? Well, if the two sides are 2x minus 2 and 3x minus 6, we can make those equal to each other. We solve for x. Alright, so we know that 4 is equal to x, or x is equal to 4. If x is equal to 4, then one of these sides of this triangle is going to be 2 times 4, which is 8, minus 2, which is 6. This side is going to be 3 times 4, which is 12, minus 6, which is 6. Well, if we substitute this 4 into this first choice, we get 10 minus 4, which is 6. If we substitute the 4 into the second choice, we get 6 times 4, which is 24, plus 5, which is 29. Well, if this triangle is equilateral, then all the sides are the same. And this third side can't be 29. So which could be the length of the third side? This 10 minus x right here, or right here. Number 10, the legs of an isosceles triangle, or the legs of an isosceles triangle have lengths of 2x plus 4 and x plus 8. The base has a length of 5x minus 2. What is the length of the base? Alright, I'm running out of room here, so we're going to draw a picture of this. The legs are congruent. We have a 2x plus 4. We've got an x plus 8. The base is 5x minus 2. What is the length of the base? So we need to solve for x first and then substitute it into the base. So 2x plus 4 equals x plus 8. Subtract x from each side. X plus 4 equals 8, and subtract 4 from each side. So our x is equal to 4. If x is equal to 4 in this triangle, we're going to substitute into this base. So we got 5 times 4 minus 2, which is 20 minus 2, which is 18. So the length of this base is 18. Alright, in number 11, we're looking for the values of x and y. We've got an isosceles triangle, this big triangle around the outside. Has two congruent sides, so its base angles are congruent. So this angle down here is 47 degrees. Now, if we're talking about this big triangle, ABC, it kind of looks like this. And these two base angles are 47. If we subtract those from 180, we get 86 degrees. 86 degrees for this whole top angle here. And since these two angles inside that top angle are congruent to each other, we take 86 and divide it by 2. And 86 divided by 2 is 43. So we've got one angle up top. This y is equal to 43. So this side is equal to 43. So now we need angle x. So x is going to be equal to 180 minus 43 minus 47. So x is equal to 90 degrees. So here's your x and here's your y. Number 12, an A-frame house. Here's what an A-frame house looks like. It looks like an A. It's in the shape of an isosceles triangle. The two congruent sides extend from the ground to form a 34-degree angle at the peak. Here's your angle at the peak, the vertex angle of the isosceles triangle. What angle does each side form with the ground? So these two angles are congruent to each other. So our 2x plus 34 has to equal 180. Subtract 34 from each side. Our 2x equals 146. And divide by 2. So our x is equal to 73 degrees. What angle does each side form with the ground? 73 degrees. Problem number 13, another isosceles triangle. If two legs of a triangle are congruent, then the angles opposite those legs are congruent, which makes this angle equal to 3x minus 50. Which makes these two angles a linear pair. So your 3x minus 50 plus 7x equals 180. If you combine like terms, then 10x minus 50 equals 180. And if you add 50 to each side, 10x equals 230. And if you divide by 10, x equals 23. So there's your value of x. Alright, if CB is the perpendicular bisector to AD, so CB is a perpendicular bisector of AD. It means it splits it in half. Intersects it at 90 degrees. CB is perpendicular bisector to AD at B. Alright, so this is actually point B up here. Angle DAC is congruent to angle ADC. Let's take another approach to this. Here's our angle DAC. It's congruent to angle ADC. So these angles are congruent to each other. If point C is on a perpendicular bisector, then it's the same distance to the endpoints of the segment. So AC is congruent to CD. We've got triangle ABC, we've got triangle DBC, and they both share this side CB. So which of the five congruent statement? Horizontal leg, angle, angle, side, angle, side, angle, side, angle, side, and side, side, side. Can you immediately conclude that ABC is congruent to DBC? Alright, hypotenuse leg says that if the hypotenuse and leg of one right triangle is congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So we can use it. Angle, angle, side. We've got an angle, and non-included side congruent to an angle, and non-included side. Angle, side, angle. We've got an angle, an included side, and an angle congruent to an angle, included side, and an angle. We've got a side, an angle, and a side congruent to a side, an angle, and a side. And we've got three sides of one congruent to three sides of another. So I'm going to say all. You can use all those statements to conclude the two triangles are congruent. Alright, which common side do triangle DHB and DEB share? If they both have DB in them, if both descriptions have a D and a B in them, the common side that they share is DB. So right here. It's easier to look at the description than it is the overlapping triangles. And number 16, what common angle do CDG and FCE share? A common angle, they both have a C in them, so they both share angle C. Alright, that concludes your study guide. So good luck on your quiz tomorrow. Don't forget to transfer your quiz answers to Focus, and that'll be under Alerts, and it will be PAM2 Quiz 7 under Alerts. And I will see you Monday via YouTube.